हेलो एवरीवन, वेलकम टू एक्सप्लेनेशन। और आज के इस वीडियो में हम कुछ बेसिक क्वेश्चंस के बारे में समझेंगे जो कि हमने अपने इलेक्ट्रिकल इंजीनियरिंग के सीरीज़ में कवर अप किया हुआ है। आज उन्हीं के ऊपर 4 क्वेश्चन सॉल्व करेंगे और उन्हें समझने का प्रयास करेंगे। तो जैसे मैंने कुछ क्वेश्चंस पिकअप करे हैं जो आज इस लेक्चर में हम कवर अप करने वाले हैं। तो क्वेश्चन इस प्रकार है। पहला है what is a semiconductor and second one is name of 5 intrinsic and extrinsic semiconductor. Then third one is difference between intrinsic and extrinsic semiconductor, and the last one is describe how temperature affects the conductivity of a semiconductor. तो इन 4 क्वेश्चंस को बेहतरीन तरीके से समझेंगे और तो चलिए। सो नाउ लेट्स सी our questions. So our first question is what is a semiconductor? Okay. तो जो सेमीकंडक्टर का डेफिनेशन होता है उसमें हम अभी ज़्यादा डीप में नहीं जाएंगे क्योंकि उसके बारे में डिस्कशन कर चुके हैं पहले भी। तो अभी कुछ पॉइंट्स हैं जिनको याद करने की ज़रूरत है, जैसे कि सेमीकंडक्टर हैज़ अ कोवैलेंट बॉन्ड and semiconductor have energy gap band between 1.3 to 1.5 electron volt. Then at absolute temperature it is insulator and at room temperature it is conductor. Now one thing more that we should consider on this, that 0 degree Kelvin we consider as absolute temperature and 300 degree Kelvin we consider as room temperature. Okay. And our next question is exchanging semiconductor. Okay. So now let's start from 5 intrinsic semiconductor material, and they were like silicon, germanium, graphene, then gallium arsenide, then indium antimonide. Okay. By the way, silicon used in all modern electronic devices. Okay. This is very common in using. Then our next thing is 5 extrinsic semi, and into this they have category N type and P type. Okay, so the material divide in two part, that is N type and P type. Okay, now let's say N type. So as you can see on the screen, there is an N type material name and also there is a P type material name. Okay, now let's see third question, that is difference between um, intrinsic and extrinsic semiconductor. Now let's talk about features about both semiconductors. And they were like, if you talk about purity, okay, uh, everyone knew about this, that semiconductor, some semiconductors is impure and some are pure. Okay. I mean, some of them are doped with some material and some of them they were not doped. Okay. Now let's talk about purity. So intrinsic semiconductor is pure form of the semiconductor material. Okay, but extrinsic semiconductor doped with impurities. Okay, and now if we talk about dopants, so intrinsic semiconductor has no dopants added, and extrinsic semiconductor intentionally added dopants. Okay, now let's see the charge carriers. In intrinsic semiconductor, there is charge carrier is holes, and extrinsic there is hole and minority carriers. I mean, but hole is bigger than minority carrier. I mean, there is a lot of holes than minority carriers. And now if we talk about conductivity, so intrinsic have very low conductivity. Okay, and extrinsic semiconductor has high and controllable less temperature dependent conductivity. Okay, and if we see applications, so intrinsic used in really directly in devices. Okay, but extrinsic semiconductor building blocks of almost all electronic devices. I mean, it used in every electronic devices that we are seeing in our daily life. Okay, and then we here it is types. So intrinsic have one type, that is pure material itself. There is uh, there is no dopant, there is no impurity. Okay, so it has only one type, that is itself pure material. And in exchanging semiconductor, N type, which is electron majority, and P type hole majority. Okay, I mean there is two type, that is N type and P type. In N type there is N type is electron majority and P type is hole majority. Okay, and now last question is, describe how temperature affects the conductivity of a semiconductor. Hmm? So let's see. In short, अगर हम shortcut में बोले तो, if temperature increases, then conductivity increases. Okay, let's see how. So how temperature creates more charge carriers. Hmm? Now let's see. A semiconductor's electrical properties are defined by its band structure, which consists of a valence band and conduction band, separated by an energy gap called the band gap. So we already talked about what is conduction band and valence band and the energy band gap. Okay, we already have discussed about this in our first video. Okay, then there is then if we see about absolute temperature. Okay, I mean 0 degree Kelvin. If we talk about on this temperature, then the valence band is complete, filled with electrons, and the conduction band is empty with no free charge carriers. The uh, so the semiconductor acts as an insulator. Okay, it means if valence band is complete with, in valence band if there is electrons, and in conduction band is empty with no free charge carrier, then our semiconductor acts as an insulator. Okay, but if we increase the temperature, the atoms in the crystal lattice vibrate, providing thermal energy to the electrons. So some electrons in the valence band gain enough energy to jump across the band gap into the conduction band. This process creates two types of charge carriers. First one is free electrons, in which the electrons that jump into the conduction band are now free to move and conduct electricity. And the second thing is holes. I mean, the absence of an electron in the valence band creates a positively charged vacancy called a hole. A hole can also move and contributes to the flow of current. Okay, so this concentration of these electron hole pairs increases exponentially with temperature. More charge carriers mean a greater capacity to conduct electricity. Okay, and I mean it means that carrier concentration is proportional, directly proportional to the e की power minus eg by 2 kt. Okay, so let's see the counteracting effect of this equation. So the career mobility, I mean, while the number of careers increases, another factor, career mobility, works in the opposite direction. So mobility refers to how easily charged carriers can move through the material when you apply a voltage. As the temperature increases, the atoms that make up the semiconductor's crystal structure vibrate more and more intensely. These vibrations act like obstacles. The electrons and holes which carry the current keep colliding with these vibrating atoms. This is known as lattice scattering. So each collision knocks the carrier of this path slowly down its overall forward progress in the direction of the current. So mobility decreases simply means that due to more frequent collisions at higher temperature, the average speed of the charge carriers decreases, making them less effective effective at conducting electricity. Okay, so our overall result is the conductivity of a semiconductor depends on both the charge carriers concentration and their mobility. That's why uh, there is an equation. There is conductivity equals to NQU mu. Okay, in where n is n is exponentially with temperature, that is carrier concentration, and T and mu is our um, elementary mu our mobility, and Q our elementary charge. Okay, so we have two competing effects, that is carrier concentration and mobility. Okay, now there is one thing that we should consider on this, that is um, exponentially increases. I mean, we use a word exponentially increases. Okay, so it goes like 1 2 4 8 16 32. I mean, doubling each time. So it means the quantity is multiplying, not just adding. So for for today, this is the last question, and in our upcoming videos we will discuss in more detail, in more interesting way, and we will try to understand more basic questions and their concepts. So the doubt in our head while reading, studying, that will be clear. Okay, so now thank you for watching this video.